Right, hi everyone. My name's Dave, and I work for Hailo, and I'm going to talk today about how we're using Cassandra at Hailo. I'm going to go through our use case, I'm going to go through the data model and some of the operational side of things, and then I'm going to talk a little bit about the perspective of Cassandra from different people at Hailo. So Hailo is based in London, and we started off in London, but we're now on 3 continents. And I've been working with Cassandra for about 4 years now, and I run the London Cassandra user group, and I've done that for about 3 years, coming up to 3 years now. And I started working with Cassandra back in the days of 0.6, and back then Cassandra was a challenge. Cassandra was something where we would come to work and we would kind of do battle with it all day to try and make it do what we wanted it to do, and we would often lose. But a lot of things have changed since then, and I went and looked it up. There's tons of features. Jonathan kind of, every time I see one of his keynotes, he's kind of introducing all these new features that they're bringing in, and it's quite staggering how far it's come. And today we're quite lucky really in that Cassandra isn't as difficult, isn't as brittle to use as it used to be. So that's pretty good work by the committers. So I'm going to talk about the kind of perspective of Cassandra at Hailo. When I was thinking about this talk, I went around and spoke to a lot of the people in our organization. I spoke to some of the developers, I spoke to the people who have to operate it day to day, and I talked to some of the management, including people kind of at all levels right at the very top. And it was quite interesting, it was quite eye-opening in some respects to talk to these different people. Because Halo's grown from a company, where we're all sat together on one boat, and now we're a bigger company. So I don't always get the opportunity to meet these people. So what's Hailo? Hopefully everyone here has heard of it. Has anyone not heard of Hailo, just out of interest? Okay, all right, quite a few. Good. Right, this is a sales pitch then. So Hailo is an app that means you can get a taxi wherever you want, and you can do it by just pressing a button on your phone, say pick me up. A black cab will come and get you. You can jump into the cab, and at the end of the journey you can just jump out and it will be charged to your card and you'll get emailed a receipt. So it kind of takes the pain out of getting a black cab, especially in some of the more obscure parts of London when it's winter and cold and wet. And for drivers, we make the life of drivers easier by meaning they don't have to drive around so much empty. They can kind of make better use of their day basically by getting these extra jobs. And they can get extra work that people might have used other services for before Hailo came along. And it was founded by this motley crew in London about 3 years ago. And we built most of it working on a boat on the Thames. And we launched in November 2011. To give you some idea of where we've come in 2 years since launch, Hailo is now the world's highest rated taxi app. We've got over 11,000 5-star reviews. We've got over 500,000 registered customers. A Hailo hail, so that's like when someone hits the button and says, come get me. One of those is accepted every 4 seconds around the world. And we're operating in 15 cities now on 3 continents, including all the way from sort of Asia over to Canada. And one of the interesting things about Hailo is that it's still growing quite rapidly. And we've raised quite a lot. We've raised quite a lot of funding, and we're going after. Hailo is a company founded with global ambition, shall we say? So we're sort of pursuing that vision. So how we came to end up choosing Cassandra is what I'm going to cover now. We launched in November 2011 on AWS, and we're still fully AWS. We run everything from Amazon, and we started off with 2 PHP MySQL web apps and a kind of Java backend. So the Java would do the work of figuring out where your nearest taxi was and some of the harder bits and pieces. And the PHP MySQL would do a lot of the basic stuff like account, CRUD, that sort of thing. We had some resilience in that we ran multi-master replication for MySQL, but we were still kind of at the whim of Amazon. If we lost if we lost 2 availability zones, for instance, we would be in a bit of trouble. And if obviously we were only single region at that point. But the whole thing was built by quite a small team quite quickly, so that's kind of where we started. And then before Hailo launched, it was all about finishing the features. You know, getting the basics there so that you could actually book a cab, they'll come and get you. Once we'd launched, there was kind of a new set of requirements really, and it was those new sets of requirements post-launch that led to the adoption of Cassandra. These are the kind of things that influenced the decision. So we wanted Hailo to become a utility. We wanted it to be very reliable. We wanted you to hit the button and it would always work. It wouldn't let you down on a cold Friday night or something. That was the plan, and we wanted to make sure the technology was solid. We had plans for international expansion. We knew we wanted to go to the US. We sort of had that in mind from the day the company was founded. And we wanted to be able to run data centers in the US so that people using the app in the US would have locality of service, so we didn't have to dial back all the way over the Atlantic. We were expecting growth. We're not an enormously high volume service. We don't have to cope with Twitter levels of traffic or anything, but we knew we wanted to scale the company up, and we didn't want the technology to get in the way of that. So we thought if post-launch, we thought we'd just try and pick something that would support that growth rather than getting in the way of it. And finally, there was some prior experience, because I'd used Cassandra before I joined Hailo, so that kind of helped influence the decision to choose Cassandra over other potential alternatives. So the path to adoption was kind of unilateral, really. The developers, this was, we're all on the boat. We kind of made the decision ourselves. We didn't, it was a startup. There wasn't an enormous amount of management oversight, and I'll sort of come back to that later. And the way we did it was we took some of the core functionality that we needed, mainly customer records to start with, and we put them into a different service, and we backed that with Cassandra, and then we made the PHP MySQL web app just simply be a lightweight wrapper to call through. And we've been progressing that ever since. And we launched that in September 2012. So that was the first time we used Cassandra in production. And now we're using it more and more. So 1 year on from launching Cassandra, we're starting to introduce it in lots of different ways, and we're really aiming to migrate all of our transactional databases to use Cassandra, because it means it's relatively simple for us in terms of developers have one way of doing things. And a lot of the kind of ways we need to use it are relatively similar, which I'll explain in a minute. And we're continuing the path of kind of breaking down Hailo from these sort of fairly monolithic, large web apps based on PHP MySQL into kind of more of an SOA based on Go and Java. So that's kind of where we're heading. So the development perspective of Cassandra, this was basically what the developers think about it in Hailo. So I went and asked them. And Dom W, senior engineer, said that he thought Cassandra just worked. And this is to some extent the picture. There are difficulties. Obviously, people don't always have experience with Cassandra before they come, but generally it's been pretty solid for us, and it's relatively straightforward for people to use it for simple use cases like entity storage. So the two use cases that we have really in Hailo are simple entity storage, so store my customer, get my customer back, and obviously update. And then also we have time series data. So I've got some examples. This is customer records in Cassandra. So the row key is a snowflake style in 64-bit integer, which we can generate globally, guaranteed to be unique without coordination, which is quite nice. And then the columns, so things like created, timestamp, email, etc., they're the column names, and then the column values are just the values for those. So this is a relatively straightforward way of using Cassandra. The key thing to remember when storing entities is to avoid kind of race conditions. Don't read the whole entity, update one thing, and then write it all back. If you just mutate individual columns that you change, then you avoid race conditions. So we kind of try and follow that practice. And this is kind of an example of kind of the volumes we're doing. So I guess the point here is we're not doing enormous volumes. This is like 20. This is only one kind of service use case, but the volume's not enormous. We're doing kind of this is a read-heavy workload, which is the blue line, and it's still only like 20 a second, so it's not that high. Although this was a while ago. Another example of data storage is time series, and this is an example where we've got a database where everything that happens in Hailo we turn into events. So when you pick me up here, or if you manage to get a taxi or whatever, we turn into an event. and we send them down a queue and we put them into Cassandra. And we store them as a time series. And in this example, we're storing them under all the events for one day under one row. And you can see in this instance, the column name here is actually a time UUID. So it's a unique identifier that contains a time component. And the value is just like a blob, which is, here's some stuff, here's what happened, here's the event. This is immutable. So once we write this in, it's immutable. So this is a kind of common Cassandra use case. It's kind of like sampling, measurements, that sort of thing, where you've got a mutable stream of data that you just want to store somewhere and then retrieve later. And I'll come back to some of the issues with this later. The interesting thing about Cassandra is you have to store the data in the way you want to get it back. So we want to be able to query the events for a job. That's quite an important use case for us. And if we only store the data by day, the only query you can really do is get me stuff that happened between this time, and it give you everything. Whereas sometimes we need to be able to say, get me all the things that happened for this job. So we store another index where this time the row key is a job ID, and we store just the events that happened for that job. So we're basically duplicating the information on ingest. So we're denormalizing on ingest so that we can satisfy two different query patterns. And that's a kind of another common Cassandra pattern. And this is our StatsDB load. So this is much higher. This is like 4,000 a second, up to 5 or 6 writes per second. And the green line is read. So in this instance, you can see it's really irregular, which is basically because it's kind of on demand. It's when people need some data, they'll go and do a query. And then at night, no one does any queries, so it just disappears. The main consideration for time series is picking a decent row key. So basically partitioning your data into enough blocks. If you go to some of the kind of fundamental Cassandra talks, or if you've used Cassandra before, you'll know that Cassandra puts data, it decides which node to put data on based on the row key. So if you put lots and lots and lots of things in one row, they're all going to be on one node, basically. We're using Gossi, the Go driver, Stynax for Java, and PHP-Cats for PHP. Drivers are still a bit of an issue. DataStax's trying to do something about that. The Gossi driver, the guy who wrote it about 2 months ago, basically declared that he was not going to take part in it anymore, and as far as he was concerned, it was deprecated, which was quite interesting when you were building your application on it. So, I mean, I guess that's the nature of GitHub and open source, but so that's the way it works. So another thing we use at Hailo is we have analytics. So as we migrate our PHP MySQL-based web app to Cassandra, anyone familiar with Cassandra will know that Cassandra's got a bunch of limitations in that you kind of have to store the data in the way you want to get it back. And one thing it's really not going to do for you is analytics. You're not going to be able to, you're going to lose the kind of the queries you could do against MySQL where you say sum up, sum, count, average, group by, basically, those sorts of things. And we needed to come up with a solution for that because obviously we're taking functionality we already have and we're migrating it into this global Cassandra. So we use Akunu Analytics for this, which is a product by a team in London. They sponsor the event as well. And this is broadly what the pipeline looks like. We have all our events, we put them into Akunu, and that stores the data in Cassandra. But it kind of hides the complexity from us of how it stores it. And it means that we can write stuff like this. So this is an example where we're basically saying, work out the number of accepts, ignores, declines, and withdrawns for a particular driver. So imagine you hit pick me up here on the app, and we're going to ask drivers if they want the job. And for every single time we make that offer, this is the information we record. And using Akunu, we can just kind of construct SQL-like queries again. So that's kind of handy, and it hides the details. And they have like a dashboard. So this is the sort of thing you can surface with it. You can draw heat maps, and you can count up. So this is an example in our test cluster of me counting the number of distinct drivers on shift, grouped by minute of the day. So it's a very quick way of getting some pretty good insight into what's going on. So operational perspective. This was one of our top operations people who I got to tell me about Cassandra and their experience of it. And his view was that Cassandra is allowing a kind of small ops team to do something they wouldn't really have been able to do without Cassandra. And in particular, he was really referring to running an active database on 3 continents. So with Cassandra, that's actually relatively straightforward. So this is Hailo. This is where we operate. We started in London, we're in Dublin, we're in Spain, we're in North America, and we're in Tokyo and Osaka now. So you can see that we're very spread out. And Cassandra means that we can run clusters in each of those regions on Amazon, and it will replicate the data back and forth between the clusters. So the grey dotted lines here are kind of VPN links that join our different Cassandra clusters together. We typically run 6 machines per region. This is kind of what we have in production now. 6 machines per region, 3 regions. We've actually got 3 clusters. I've only drawn 2 of them. We've got another one now. We're using a dedicated cluster for the Acuna backend now. And the stats cluster's only got 2 regions, interestingly. We tried to make 3, but we basically failed to stream all the data to Japan. It took about 3 months, then we gave up. So it's cross-region repair is an interesting problem, which I don't think is entirely solved. But with the volume of data we've got in our operational cluster, it hasn't been a problem yet. We organize it. We use the EC2 snitch, which means that it kind of knows about EC2, and it will arrange the replicas such that it spreads them out into different availability zones and different regions. So if you lose an availability zone, you should still have a replica, basically. So we use that. And at the moment we're using M1 large machines and provisioned IOPS EBS for storage. Both of those things are terrible, really, and you should definitely not do that. We're currently in the process of changing to use ephemeral disks, and we're going to use M1X large machine sizes. When we first started using Cassandra, we kind of used that balance between needing enough replicas so that you can tolerate failure, but not spending an enormous amount of money to service not very many requests. So that's where we were. But now we're putting more and more stuff onto Cassandra. It makes sense for us to have have larger nodes, basically. Just some quick details about some other operational aspects. Backups, at the moment we're doing EBS snapshots, and that's kind of the only redeeming feature of EBS, which is that you can just snapshot the whole volume instantly and then keep it. But it's not really worth the payoff. So this is one of the main things we need to figure out to move to ephemeral, and we have a solution in place, but I'm not 100% sure what that solution is actually. When we launched in NYC, there were a lot of requirements about data security. The authorities in New York were very particular about the sort of equivalent security you have to go through for payments, but then with a load of extra stuff on top just for the taxi authorities that they needed done. And one of the requirements is we have to encrypt all data at rest. So we encrypt all of the volumes that Cassandra runs on, and we found that that's actually really relatively straightforward to implement and doesn't really add a lot of overhead, so we just use DMcrypt. So that's a pretty good solution. We use DataStax Ops Center, which is just a really easy way of getting some pictures of your cluster. So this is like a relatively healthy cluster. You want all the balls to be roughly the same size. It's a useful tool, especially in terms of getting people who come from a background where they're not familiar with Cassandra and then kind of trying to get some insight into what's going on. Multi-DC is a really important story for Hailo in terms of Cassandra use. So this was kind of one of the killer features for us. We started off just having machines in Ireland, and then we brought up the US cluster, and we were able to join them together without any downtime at all. So we could basically grow from a single region cluster, and now we run a cluster that spans 3 continents, and we could do that with no downtime at all. So that's quite impressive. And if you go back to the idea of being a utility, this is a kind of important point for Hailo. We don't want to have to say, oh, you can't get taxis for this hour of the day while we do a bunch of data migrations. That would be a terrible thing for our customers. We turned on compression. I think Jonathan mentioned it's just default now that it turns it on. And for us, it was a big win. It took the data volume per node down substantially. And the stats cluster in particular is still a bit of a problem, but it was becoming a problem in that we just had too much data per node, and the nodes were under-specced. But at the point when it was a real problem at the crunch time, we didn't really want to add any more nodes for kind of cost reasons. So we added compression, and we managed to go from we managed to halve our data volume, which was pretty nifty. So that was quite an easy win. So management. This was the one that was probably most eye-opening for me when I went and chatted to the people who run the company. The management perspective of Cassandra. So this is from Simon, our something or other Vice President of Operations. And I thought his quote was quite interesting. He said, "The days of the quick and dirty are over." And kind of what he meant by that is that when we had everything in MySQL, he could go and tap anyone on the shoulder in the company and say, "Can you just go and count up these things and tell me, how many people did this between this time?" And they would probably be able to do it because most people have enough understanding of MySQL to be able to do it. Whereas with Cassandra, I think there's 2 points. Number one is that unless you store the data in the way you want to get it back, you can't really get it back without jumping through some reasonable hoops, like setting up Hadoop integration, for example. And the second point is that I think it gave people an excuse not to do things they didn't want to do, which was, the developers don't really like doing these ad hoc stuff. So if you can just say, well, Cassandra, I can't do it anyway. But it's interesting for management that basically when we migrated to Cassandra, we took away functionality from them. We prevented them being able to do something that they could do before we migrated. And the COO kind of echoes that. He was saying to me that he feels it's like this beautiful solution that we've implemented, but he was the concern. They have concerns. So technically they trust that we're making decisions, but they don't really understand the trade-offs. We didn't explain them carefully enough. And the main question they have is that they feel that we've ended up in this situation where we've migrated to a database that basically no one can get data out of, except for a few skilled professionals, and even then against some tight constraints. So this is kind of the perception. I'm not entirely convinced this is necessarily true, but this is the perception from management at Hailo. And the last point from management was that they were worried that we've got this big database, we can store everything we ever want to, disks are cheap, etc., etc. And they're worried that we're basically causing ourselves a big data problem. So this is an example of taking, one of the things that makes Hailo operate is that taxi drivers send their location to us, regular intervals, so that we know where the best taxi is. So when you hit the button, we can pick the nearest driver and offer him the job. So we collect all that data and we put it in Cassandra. And this was taking a subset of the data. So this was about 1 or 2 million points or something, and then just plotting them against a black canvas in London. And obviously, you end up with a map of London because taxi drivers drive down roads. So, ta-da! The interesting thing is this is a subset. This is like a couple of million points. So this was done a while ago. We've got 3 or 4. I don't know. We've probably got 10 billion points now. We've got all this data, and we're storing it in Cassandra. And the question is why are we storing it in Cassandra? What is the actual business purpose of storing it in Cassandra? Because obviously it does cost money, and developers will do things because they can do them, and Cassandra means you can do a load of stuff that you couldn't previously do. You couldn't previously store 10 billion points in MySQL. That wouldn't have worked. Whereas you actually can do it with Cassandra if you add enough nodes. So that was another interesting insight from management, which was about are we making sure that we're using these technologies for things that matter and things that are going to make Hailo a better company, rather than just because we can. So lessons learned now. There might be a golfing experience. So people joining Hailo typically have no experience of Cassandra at all. We have been trying to hire effectively a DBA, someone to come and look after our Cassandra install for about 6 months, and I think we've had about 2 applicants, and neither of them have ever used Cassandra before. So this is a bit of an issue. When developers join the team and we say, build this application, use Cassandra, typically they will enter the company with 10 years of MySQL experience, and then we're asking them to use this technology that they've never used before. I don't think anyone has joined Hailo and having used Cassandra before, so it's all new. So the interesting thing about that is that one of the lessons that we've learned really is that you have to hit that head on. It's not necessarily a problem if you address it in the right way, and these are some of the things that we think help. So the first thing is you need to have an advocate. So people joining your company with no experience with Cassandra and then being asked to develop some application to a tight deadline against this thing are probably going to run into issues, and they might end up hating Cassandra because you're preventing them hitting their deadlines, and it makes them feel bad and look bad. So you need to have an advocate. You need to kind of sell the vision of why have we picked this thing? Why are we asking you to use this data store? because we're operating multiple regions and resilient. So you can sell it, but you need to do that. The second point is kind of learn the theory. So with Cassandra, I still think it's really, really useful to understand how the data is stored and to understand how the data is distributed around the cluster. So to sort of understand the fundamentals of kind of Dynamo for distribution and the big table for data storage, because it does help inform how you go about building your application, basically. The CQL stuff that seems to be really popular now is a good thing for reducing the barrier to entry, in that people will come and think they have familiarity. But also it causes its own issues in that it hides some of the details. So you could be using CQL and thinking it's kind of, you're using a relational database and you're not, basically. So it's an interesting problem. And then finally, just make an effort to get everyone on board. When we unilaterally adopted Cassandra at Hailo, we probably didn't put enough effort into getting everyone on board. There are a few key people in the company who were kind of grizzly old Java devs who were quite stuck in their ways, and we probably didn't do enough of a job of selling them why we were choosing this thing. And sometimes, if there were any problems at all, that kind of split opinion about whether it was a good thing would surface to management, and management would be a little bit unsure. Whereas if we'd have just put a little bit of energy in the beginning to just get everyone to agree to this project, we would have probably been in a better place. Secondly, second learning, things can drift into failure. This is when things don't look good from Ops Center, by the way. If you see this, then something's not right. So this is, we want all the balls to be the same size, and we want the streaming to be not doing that much streaming. So this basically tells us that we've got a really unbalanced cluster, lots of things are streaming to lots of other things. We're doing all this extra I/O work to try and get the cluster back into a sane state. And while this is going on, the application will be having problems. Interestingly, we were able to continue. We were limping on, but not brilliantly. This was actually our stats cluster, so it's not. Luckily, we'd already foreseen that it would be a useful thing to do to partition by use case, so we have a stats cluster that isn't required for getting you a taxi, but still. So it is kind of easy. It's easy to shoot yourself in the foot with Cassandra, as it is with anything. I guess this is another point about experience. When people join your company with 10 years of MySQL experience, they're probably not going to make mistakes like creating terrible indexes or no indexes on a relational database. Whereas with Cassandra, they might make similar things that once you've been using it for a while, you'd go, yeah, definitely don't do that. But they wouldn't have seen it coming. So this is, we've really recently, this is kind of in the last week, we've had someone in to kind of help us look at our Cassandra cluster. We had Aaron Morton, who's doing a talk later, and we basically got him on site for a day just to have just to say how we're using Cassandra. Are we doing it well? And he pointed out some interesting things, which is this is the output from CF histograms, which is one of the no-tool commands, a really useful one. And the arrow points at the number 480. And for this particular column, what it means is that 480 queries had to go and look in 6 SS tables to get an answer to our query. So basically, if you know anything about how Cassandra works under the hood, whenever you write data, it's putting it into SS tables, and they're immutable, and it flushes them to disk. So if you're updating things often, with lots of SS tables, and if you do a query that is something like select everything, select all the columns in this row, Cassandra has to go and look in every single SS table, basically, and that can slow your performance down. So ideally, you would want less queries to be looking at that many SS tables. And in this instance, for this particular column family, Aaron pointed out that it indicated that we had like a mixed workload. We had some relatively static customer data that pretty much never changed, and then we had some dynamic bits, and we were storing them both in the same place. And what that meant was that every time we updated one field, we kept generating more entries in more SS tables. So to gather the customer row, we had to go and look at all this data. Actually, most of the data we're updating, we don't really care about when you need to get a taxi. It's the stuff, the static stuff. So it'd be much better splitting the use case, because then we'd have a column family. We'd be sort of separating out the data that doesn't change very often from data that changes all the time, and that's a good pattern. This is the same output, a different column. We've lost the headers now, so it's difficult to understand what this means. But This is the read latency column. And what this actually means is, and we're missing a little tiny bit off the left, but this means that 1,043 queries took, you have to go right the way back to the left column, and it's that many microseconds to complete. And the interesting thing about this, as Aaron pointed out, was that we have a bunch of things that are completing in 20 microseconds, and you know, a really short amount of time basically. A fair amount of queries complete in almost no time at all. But then we have down here, we have still a reasonable number of queries that are taking, you know, orders of magnitude longer. And he was pointing out that, you know, maybe this indicates you've got a problem with I/O, not enough capacity, or maybe again data modeling problems where it has to go and look at all these SS tables. So there's some interesting things you can, you know, get from your cluster just by running CF histograms. The other obvious one to run is CF stats, and this is an example where we have a row size that's actually 16 gigabytes. So this is the biggest row in this column family is 16 gigabytes. Aaron's advice to us was that he reckons if you've got rows of like, you know, 50 meg, he would probably ask you a question and say, are you sure you've got the data model right? He said if you had a row of about 100 meg, he would probably be saying to you, please change the data model. So he wasn't that impressed with our 16 gig row. Suffice to say, this is because we're doing time series and we picked a bad granularity. So we're storing everything for one day in a row. And as Hailo grows, that means that the rows get bigger and bigger and bigger. And because of the way Cassandra works, you know, it basically doesn't like big rows. So keep an eye on that. So lessons learned, be proactive basically. We thought our Cassandra cluster was running really smoothly. And most of the time it was, but it's worth checking these things out occasionally. Go and look at CF stats, go and look at CF histograms. Peer review data models, spend a bit of time designing data models, especially if you keep in mind that you're going to have people with no experience or little experience, you know, building applications on top of it. It's worth just taking a bit of time and saying, why are you storing everything for one day under one row? Is that a good thing to do? Mixed workloads, again, it's worth keeping an eye out for those and trying to separate things. Different column families is a good idea. And basically just keep an eye out for other signs, early warning signs of data modeling problems, I guess, is the key. The other interesting point that Aaron raised with us was about compaction strategy, and he was saying about if you're doing a lot of overwrites to column values, it's worth thinking about using leveled compaction because it's more aggressive with basically doing the compaction and reducing the number of SS tables. I'm pretty sure that's what he said anyway. But I guess his point really was, you know, you don't need to have the same compaction strategy for every column family. So it's worth considering, you know, what does this column family do? What are the read and write patterns, and what are the best settings to make this work? Next learning, EBS is terrible. So whenever Amazon have a problem, it's nearly always EBS. For anyone who doesn't know, EBS is kind of Amazon's network-backed, you know, magic storage thing. When EBS fails, it's gonna, if every Cassandra node is using EBS and EBS goes wrong, then every Cassandra node stops working at once. So it's kind of a thing where, you know, you've got this, we've got this brilliant distributed database, you know, no single points of failure, except they're all using this one thing for storage. So, you know, if EBS goes wrong, it all stops working. EBS is generally slow and expensive, and really it's unnecessary. I think it's, I don't really know anyone who uses EBS except for us actually, but we're going to change pretty soon. And I think the only thing is like a fear that you've got your data in these ephemeral drives, and if you stop the instance, it's all going to go away. But you have to bear in mind, I mean, we have 9 copies of every single piece of data because we put it into 3 replicas in Europe, 3 in the US, and 3 in Asia. So that's probably enough. Next point, management. So we should have done better at explaining the trade-offs, basically, of Cassandra. We should have kept the business informed and let them know, instead of, you know, migrating to Cassandra and just selling the positives of, you know, oh, resilience, all these brilliant features we're adding in. We should have pointed out to them that actually you're going to be, you know, one of the trade-offs is going to be that we're not going to have as easy ad hoc access to the data. And then we could have decided whether that was a problem and maybe implemented a solution, because there are, I mean, you know, there's things you can do. You can you can run DSE and then have the Hive integration. You can bake your own Hadoop integration. There are ways of solving the problem, basically, but we should have done better at thinking about that. Sing from the same hymn sheet is really just making sure all at Hailo we should have made sure all the senior people were on board with this project, the Cassandra project. I think everyone is now, but there were some times during the life cycle of our Cassandra adoption where it would have been really good if everyone had been, oh yeah, Cassandra's the way, rather than at any sign of any trouble at all, questioning it. And then what we could have hopefully ended up with is, to sort of allay management fears, we could have tried to end up with a situation where we put in place solutions from day one, basically. So we could have looked at that problem of, maybe we're going to be reducing the kind of feature set, making it harder. But we can put in place this other solution, which means that when people join, they can pretty much do it. Maybe Hive would have answered this, I'm not sure. But we should have done better on that. All right, so just to quickly wrap up, we like Cassandra at Hailo, and we like it because we feel it has a solid design. So we're building on something that has solid design principles at its core, and it seems to have been well thought out in terms of how it operates and the trade-offs it's making. The kind of masterless design of Dynamo and these sorts of things. We like that. We like the HA characteristics. We like the easy setup for multi-DC. So we'll probably end up in 5, maybe 6 data centers as we continue to grow. And we like the simplicity of operation. Although it's not without its issues, e.g. trying to hire people who know about it, it hasn't really caused us an enormous number of problems at Hailo. And we haven't. Right now we're doing a little bit of work to kind of just get back on top of it, but until now we've pretty much left it alone. In terms of successful adoption, I think having an advocate is probably the single most important thing in my mind. You want someone who's going to go and, if everyone in the company, if all the developers believe in it, then your life's going to be a lot easier. Because when things go wrong, they're still going to believe in it rather than blaming the tool. And other stuff like, invest in the tools, try and make people's life easier, try and smooth, do what you can to smooth the curve of adoption between people who come in and have no experience. So the future for Hailo, well, we're gonna continue with Cassandra, and we're migrating more and more stuff to Cassandra. It's plausible that by this time next year we'll be running pretty much purely on Cassandra. I think that's kind of where we're heading. We're looking for people with experience running Cassandra. If you're interested, you could always grab me. We're going to try and expand our reporting facility. So that problem of, can people do ad hoc queries, we're going to try and address that. That's one of the projects that we've kind of got ongoing at the moment. And we're going to continue to grow Hailo into a global business. So that's the end. Thank you. Any questions?
Yes. One question for me here is how does your amount of traffic relate to the amount of writes? I mean, like, what's your? Because you said that you're getting what you said 20 updates a second now. That's what you said about for one.
That was reads. It was 20 reads, and the updates were really low.
Okay. So you have like 5 updates, say a second.
Yeah.
And how many writes do you do for each update?
It varies. It really does vary. That was basically one column family.
Okay.
Out of 30 or something. So I'm not really sure. It does vary. Some of them, like the stats one, is really write heavy.
Yeah.
We're just doing 4,000 or 5,000 writes a second, and almost virtually no reads really. And then some of the stuff like customer details. Ideally, we should split, like I said, into 2 column families. So one of them would have almost no writes and not that many reads, but a reasonable number. And the other one should be lots of writes, very few reads.
So effectively, do you write a lot of updates as opposed to inserts of new fact, like?
Do we update? Yeah, we do. We do have use cases which update a lot, actually. I'm not sure that's a brilliant pattern. So the customer, we update things in the customer. When you use the app, we'll update, last logged in or whatever, and last did something. We'll do things like that. So we are doing a lot of overrides. I'm not 100% sure that's a good idea, but we are doing it. Yeah.
What data do you collect from cabs?
From cabs, we basically need their location so that we know where they are, so that we can offer them jobs. So if I say, come pick me up, we know that there's 3 cabs around you, and we'll offer them the job. That's basically it.
Are you getting feedback
From the cabs?
about transaction? Cab really use pick up customer.
So the cab has, Halo's entirely app driven, so that the customer has an app, you can download it from the App Store or from Play, and the driver has an app as well. So they have an app that basically just sends us where they are regularly. Does that answer your question? Okay, go on. At the moment we're running 1.1. Yeah. The upgrade process has been pretty smooth, but we've not tried to keep up with the bleeding edge. We've sort of just kept behind, tip or whatever you want to call it. I've got time for one more question. Last one. I don't know. The question was, why are you using VPN and not SSL between the data centers? I'm not that ops focused. So I don't know the answer to that. I could try and find out. Really quickly then, last one.
I will let the issue also with application also for Windows Phone.
Windows Phone.
It's not yes.
And I don't know. I'm not sure. I'm not in charge of the product roadmap. Probably not. Any more questions? Feel free to come and grab me. Thanks very much.